Let me ask a very simple question. Suppose I have built an AI agent for doing mathematics, and I have built another AI agent that is super amazing at writing. Why can't they work together? Why does my math agent need to learn the writing? And why my writing agent need to learn the math? Why can't a specialist stay specialist? And and why can't one AI simply ask another AI for help? That's exactly the problem we are solving today. Because one agent start when one agent start talking to another agent, you are not building AI tool, you are building AI team, and that's where things are getting interesting. Hey everyone, welcome back to the series. In this series, we are building AI agent from scratch, first learning the concept and then deep diving into the code. So in previous episode, we already explored a lot of things about related to AI agent. We learned about the function calling, we learned about the MCP server, OpenAI integration, deployment, and but there is still one piece still missing. Today, our agent can talk to tools, but what if what if it could talk to the other agents? That's what A2A solves, agent to agent communication. And by end of this video, you will understand how modern multi-agent system actually work. So let's deep dive into the thing. So look at this picture. We have our agent. Uh, that is something, let's say one agent, and we have one math specialist agent and one writer agent. So if we are building some system, sort of with these, this is the setup that human team work. There is a manager doesn't do accounting, there is accountant doesn't write marketing copies, specialist do the specialist work. And that's the core idea behind the A2A. Let's understand what is the A2A. A2A stands for agent to agent protocol. It's developed by the Google, now Linux Foundation, and it sort of help us to discover my AI agent, the other AI agent, and delegate tasks, coordinate work, regardless who built them. And if you just think through by the concept we have learned so far, one concept we learned so related to the MCP. MCP, we have a single agent. It's connect to the server, find out the tools, and ask the tool to run, and then use that output and run the get my result. But in A2A, my one agent go to the task, ask for other agent and ask for the some task, and then maybe delegate to other agent and then get the output. So it's simply my agent is talking to other agents. It's like a more like a community of agents. It's a multi-agent, that's why we call system. So MCP connects agent to the capabilities, but A2A connects agent to the other agent. So now we are building a sort of a multi-agent environment. Idea is very simple, but massive implication. Because now an agent can delegate work instead of doing everything itself. And that's why I am using the term specialist. So we are going to build a specialist agent. So what is the core idea behind these things? So there are only four things you need to remember. Very simple. One is the agent card. Very simple. Who am I? What can I do? Second is the task, work being assigned. Third is the message, how agents communicate. Very simple. Artifact, the final deliverables. If you understand these four concepts, you understood 80% of A2A. Very simple. But now let's understand why do we need the A2A? As I mentioned in the one line, it helped me to communicate between agent to agent. But let's understand a scenario. My single agent is like an island. If we integrate all this island, every integration is sort of a custom for my island. Every team's reinvent communication. With A2A, any compliant agent can discover other agent, read its skill, send it work, receive the result. Sort of a, think about what HTTP does to websites. Before HTTP, everything was custom. After HTTP, everything could talk. A2A aims to do the same thing for agents. Now let's see how we are going to do. So this is a very basic sort of a AI agent card that we are going to build, and we will show you how this is the very a card is named my math specialist is something tell who am I, description, what do I do, and this is the URL where to find me or what is my address. And this is the capabilities, like what features do I support? And last is the skill. What specific task can I handle? Very important. This card is super important because by this sort of a identity card, my other agent is going to find me on the environment and then run these things. So these are simply help me to in more like a discovery. Now let's see a very simple demo. This is my very simple agent that I'm going to build is, let's say, repeating a hello agent. So my agent card is I'm building here. This is my agent card. My name is hello A2A agent. Description is simple greeting agent that echoes your message. This is my URL. I'm running on my localhost. I already uh, showed in the previous video how to run it on internet and all these things. But just for demo, we are running locally. This is the version, and this is the sort of a default input. But this is my skill. Like ID is the name is the greeting, and respond with a friendly greeting, description, and text are hello greeting. This is my agent skill I'm putting up. Now, how to define my agent? There are two parts. So one is what my agent can do. Is simply my agent is like description is this actual agent logic. Simply it's doing the returning a hello from it way you said something. There is a message I'm getting here. So it just say hello with the message you pass. Now second part is I know this logic, but now I need to connect to the A2A protocol. And this is the second part, how it sort of extract the message. So I am getting one context and there is an event queue. So from the context, I try to find out what is the last message. In this context, like context message is there's a part, I iterate through part and get the root message. And the root message will be the user message. And I will pass this user message to my agent that I defined here. So it will run my agent and get an output. Run the agent and I got my response. Now, instead of just returning to the message, I will update my task updater, and then updater will add the artifact that I am returning. Artifact is my the return output that I'm returning. I will explain a little bit better, and then updater will complete. Task will complete. I will explain all this step how it will do one by one. But this is two part. Very simply, it extracts the user message, run the agent, and send the result back. But in a node, just return loop and all, and that's how my agent is defined. What it does. So how I am going to run it? So let's say I first run my Jupyter, and this is my. So let's see here. I will run my Python 01, my hello A2A, and I will get. I need to check. This is the one curl command that I have defined it to find my agent. So that's the agent card because I want to see. So this is the URL. I can find my agent, and I need to find what is my. This is the curl command. I will run it, and that's how I got my agent card here. So by running it, I got my capabilities, default input message, and hello from A2A, preferred JSON RPC that I'm defining, and this is my URL and version everything. So I got my simple what is my agent is doing. So let's say uh, that's helping me. I got okay. I have one ID. I have one address. From there, I can find my the sort of my agent. Now it's till now it's very simple. Now let's go to slightly a more better example. So we will do a different agent that we call, let's say, our math agent that we mentioned. So this agent is a math agent that typically run all the mathematical expressions for me. And this is the same executor. Try to find out the user message, run the agent, run the solver, and then update the output. And if cancel if not supported, and this is the agent skill calculate, math calculation, expression, and math calculator arithmetic. Simple. This is the same part. Now let's try to run it and find out how does it work. So if I do Python 02 math agent. Okay. Oh, my math agent is already running. So yeah, it's running here. Controls. So here it is. My math agent is running now. If I want to see it, I can simply run check what is the agent card. I simply change the port because it's running on 8000. It's running. Now I got my math agent. Same, I can go to my writer agent. This is running on port number 992, 9002. I can directly go and do my curl. So I can see my agents are reachable. My both agent is now running agent on 9001 and 9002. One agent I closed it. So my both agent is running it. And how this is one? My math agent is implementing math calculation. My writer agent is calling OpenAI here and responses API. You are a skill writer. I wrote a prompt, a different sort of agent. Internally, it called. It doesn't matter what it's doing. My agent is doing. Simply, I will pass my message and get an out. That's the idea. That's the core idea. So agent skill, there are two skills. One is the writing and one is the summarizing. My agent has now two skills. Very interesting. You can add more skills to the agent. And now let's see what is skill. When we are saying skill, let's say agent card can list multiple skills. As I saw, there are two skills. Specifically, capabilities the agent can offer. Other agent read these to decide who's to delegate. Because there is a one agent who will sort of delegate this task. We call it orchestrator. I will show the how orchestrator works. So skills are incredibly important because skill determine routing. The orchestrator doesn't read your code. The orchestrator read skills, better description, better routing, better multi-agent behavior. So that's why this is important. So as we are showing, ID was for like this calculate, summarize, there was a name, human readable name, and there's a description, and there was a text, math, arithmetic, all these things. So single skill agent, single one calculate, but the our other second agent was the write and summarize, they have two skills. So skills are very important as you understand for the orchestrator to understand what should I assign to this agent. Now let's understand sort of a uh very basic concept when we're dealing with okay MCP and the A2A. So everyone okay, this is sort of very important to understand the difference. They are not sort of a competitor. MCP gives agent A2A gives agent a sort of a teammate. You are going to use both. So as we are showing, because I'm going to use multiple agent, and that's one agent can talk to other agent. So these are the different things: what to connect agent to tool, agent to agent, discovery, the tools list and or sort of function calling. This is the agent card. How to do the execution, multi-turn? No, because we ask the answer and we get an answer. But we can sort of there is a life cycle I will explore, and there is a multi-turn. In typically tools called no, we ask some question and get a result and respond. That's it. That's the result is JSON, but we have an artifact here. Transport over to HTTP, but an STDIO, I mentioned in my previous episode, but here we have more advanced HTTP, SSE plus JSON RPC. Think of like giving an agent tool, and second one is sort of a teammate. As I mentioned, this is they are sort of a complementary, not contradictory. This is very important to understand the difference between both. So how does my task flow through A2A? This is sort of a life cycle, how we are going to use. So I submit one task, it goes to in working stage, and if required input more clarification, it asks. But in tools, it doesn't. Here, it can ask for more clarification. It completed, then result ready, push to the queue, and then if failed, error occurred. This goes in this way. Very, very sort of a key insight, input required. The agent can ask for clarification in a sort of a mid task. This is how human in the loop patterns survive agent to agent handoff. The orchestrator or the human can reply and the task resumes. Sort of it, the agent asks, okay, you are asking for this new sort of mathematical task. When you ask for summarization, it will ask, okay, do you need the longer summary or shorter summary? You reply, okay, I need a shorter summary. Then in between of task, it takes this input from the human or maybe from other agent and then continue the task to fulfill the final output. That sort of a compared to MCP tools follows a fire and forget. A2A task are multi-turn conversation. This is very powerful thing that we are getting out of it. Now let's understand how our agent communicate. Very important part. Because agent, okay, I know one agent is there, second agent is there. Now how they are going to communicate? So there are two parts, messages and artifact. So message is a thing that you send to the agent. There can be one or more part. Text can be there, data can be there, file can be there. And second is artifact. What agent my agent produce? So it can be one or more artifact like text data, files, PPT, anything can, because my final agent can return anything. Sort of it's the output of my the agent that I'm getting it. So it's sort of a rich deliverables, could be paragraph of text, generated image, spreadsheet, Excel. and multiple things sort of we can get from it. So this is sort of a tool that return this sort of value. So tool returns sort of a very values that we do, but agent returns the artifacts that we call it deliverables or artifact. Okay. Now let's understand how agents find each other. So this is sort of a we first create our agent card, agent publish that card, client fetch that cards, and client pick agent which agent I need to delegate, and which to delegate means I'm the orchestrator in the point of view I'm saying. So I will decide whom to I will fetch all the card. I will decide whom to give the task. So client then orchestrator or the client send the task to that specific agent based upon the artifact or the task they are saying I can do it. Now let's say this is sort of our first A2A agent that I mentioned. Hello A2A. Very simple. This was a sort of a the code execution. It wait and run the message and then get output. So it's a very simple couple of line of code, not huge, but you need to install and understand A2A. That is the very simple. You will keep install A2A and SDK. Both will help. Now when we are saying uh, we have two specialist agent, the math agent and a writer specialist agent. As we can see, are both agent. So my math agent is can do simply the mathematics formulation, all the mathematics work. But if I go to my the writer agent, it can do sort of it's calling the OpenAI in the backend, but you don't need to worry about it because it is simply agent. You don't need to care what is running inside the agent. As of now, you just need to see what is the skill. So my skill is it can do the write, so content writing, and second it can summarize the summarization. And that is the my second agent is having two skills. So now my most important part comes is how is my Marco orchestrator is going to discover and delegate. So we already saw some bit of discovery, how my agent is going to discover. And now it's a more important part is the delegating. How is my orchestrator is going to delegate? So if you just see this part, the orchestrator. So my orchestrator is having first find out all the agent discover agent, and then based upon the sort of this, based upon my task, it will delegate the task for math, and then again for writer, and again for writer. So it can do the delegation. Now, very interesting. Let's see how it can delegate and do the chaining, taking the output from one agent and again feed into other agent and then do the sort of a combine all the output, give me the final result. So now let's run this. So I have running my both agent, that is math agent is running on 9001, agent second is running on 9002. Let's run the orchestrator agent. So if I start the orchestrator, so first it discovering the agent, it find out both the agent. The math agent is running on 9001, writer is 9002, and skill is content writing and summarizing. Now I ask what is 14, 42 and 17 plus 3. So it gave me the final result. And now I ask the delegator writer, write two-sentence summary of what MCP is. It wrote, it gave me the output because it's using the OpenAI in the backend, as I mentioned. And now I will chain the result in math result plus my writer. So I will ask, write a fun fact about the number that I got from my first agent. So it will say the fun fact is what do you mean multiply by, and something is just something forward and backward. So it because it's saying a palindrome. So nothing interesting, but I just want to show how this orchestrator can work, find the agent and delegate the task, and how they are communicating and how sort of they're doing the chaining. Let's run the discovery, test discovery. How I'm going to discover my this thing. So is agent simply by the URL known. So this is the well-known agent card that I was the URL, the curl command we were running. It's a breakdown of this thing. So just for understanding how I'm finding out where is my agent or what is the agent do. So I can get the agent card and will extract name, description, version, and skills from there. So there can be multiple skills. That's why there I'm iterating here. So this is very important because if I just add the one skill, you will just first skill, but my agent can have multiple skills. So now let's run this test discovery. So now my test discovery, go to the math agent and try to find all the things, what can I tag, and same for the writer agent, and got all my things. So this is simple, very easy, not a very complex task. So this is simple function that we are using. Now let's go to my final part, the complete stack. Python. So how? So this is where everything final clicks. Function calling. My layer one is the function calling that I'm doing by SDK, OpenAI, and all. There are the tools, the parameter, and then function calling go to the MCP. MCP roll up to the A2A. Not they are not competitors. It's layers. So function calling model calls the tools, MCP agent tools ecosystem, and A2A agent to agent ecosystem. Each layer builds on the previous one. So it's sort of a that's how we are learning first agent and then MCP, then A2A. So they are layers. They are not the competitor. That's a very important part. And we are going to we are going to use everything together. Now we already know these are the three layer function calling, MCP, and A2A. And at the end of this, we are going to understand the whole. That's how we are going to build the whole team. And that we saw. So these are the four things for building the multi-agent card, task delegation, discovery, and chaining. That's the output taking out to other output, in one output to other output, and that's what we're doing. So uh, today, what have we learned? Today we learned about the sort of what are the agent card, how it's doing the delegation, multi-agent system because we try to uh, connect all the agent, how the agent discovery is happening. So and this is sort of a multi-agent system that we have explored in this quick episode. So most importantly, you have learned that intelligence doesn't have to live inside one giant agent. Sometimes the best agent is a team of specialists, or sort of I would say the best system is a team of specialists because you are not going to build agent, you are going to build one system, one sort of a huge system that you are going to build exactly like the humans. No matter you need to connect the computer system with the human thing because we are always say LLM as a brain. We try to connect these terms together to give more intuition about the things. Now we have reached the sort of a final piece. You know the function calling, uh, you know the MCP, you know A2A. The question is, what happens when we combine all three? One application, one orchestrator, multiple agents, MCP tool underneath, a complete production grade AI system. And that exactly what we are going to build in next. And it's going to be bring together everything you have learned in this series so far. So if you are loving this series, like the episode, subscribe to the channel, and keep learning. See you in the next episode. Thank you. Bye bye.